Have you ever wondered how the painting mechanic in Meccha Chameleon actually works? Welcome to the second episode of Behind the Mechanic, where we reverse engineer popular game mechanics and rebuild them from scratch in Unity. Today we are recreating the painting mechanic from Meccha Chameleon, a game that has recently caught the attention of many players with its unique hide-and-seek gameplay. By the end of this video, you will have a fully working runtime painting system that lets you paint directly onto a 3D character, control the brush's color, metallic, and smoothness, and even pick colors from the environment just like in the game. So let's get started. Let's start with an empty scene. First, we'll be creating a script to store the brush preset like the color and brush radius. I'll name it paintbrush config. Let's delete the start and update and also the mono behavior, as this will just store the data. Let's create a variable brush color, and I'll initialize it with a red color, and another variable float radius, and I'll set it to a value of 32. I'll make it serializable so that it can be visible in the inspector. Now let's go back to Unity and let's create a sphere on which we'll be painting. For the painting mechanic, we'll be using raycast to detect which part of the object we want to paint. So we need a collider on the object, but specifically a mesh collider, which I'll explain why in some time. So we'll just remove the sphere collider and add a mesh collider instead. Let's bring the camera closer to the object. Now for the painting mechanic to work, we need a base map or albedo texture on the object so that we can paint the pixels on that texture, but this sphere material does not have any texture. So we'll be creating a script that will assign a white albedo texture to the sphere. So let's create a script. I'll name it paintable object. Delete the start and update. We need to create a texture2D variable. I'll name it runtime albedo to store the texture that we'll be generating. Let's also store the renderer from which we'll be getting the material to assign the texture. We'll generate the texture in the awake function. First, let's get the render component from this game object. Now we'll be creating a runtime albedo texture. Let's keep its size 1024 by 1024 and texture format RGBA32 for the red, green, blue, and alpha channels, and generate maps to false. For more information regarding texture creation, you can find in the Unity documentation which I've included in the description. Next, we'll be creating an array to store all the pixel colors of the texture, since the texture is really just a large collection of pixels. Its size will be equal to the product of the width and height of the texture. Now we loop through the entire array of pixels and assign it a white color, as we want our object to start with a white color. Now we just call the function setPixels on the texture to set the pixels to white and then apply it to make it visible on the material. After that, we just get the material from the renderer and set its base map to our created runtime albedo texture. Let's go back to Unity and add the paintable object script to the sphere. Now when we play, if we expand the material, you can see it has a white texture assigned to the base map which we created in runtime. Now let's create the script which will raycast on the object and have the painting logic. I'll name it painter controller. Let's create a variable to store the camera. We'll also be storing the paintbrush config. We'll be doing the raycast in the update function. If the left button of the mouse is not held down, then we'll be returning. Otherwise, we'll create a ray from the mouse position using camera.main.screenPointToRay and use physics.raycast to check if we hit an object in the way. If that's true, we check if the object has a component, paintable object, and if it does not have, then we return. Next, we create a vector2 variable to store the UV coordinates of where the ray hit on the texture. For that, we use hit.textureCoord, as the hit info not only stores the hit position, but also the texture coordinate where we have hit the object. This is why we used a mesh collider on the object instead of any other collider, as it stores the UV information of the mesh while other colliders don't. And this UV coordinate is normalized, meaning its value is from 0 to 1, so we'll be converting that into pixel coordinates. So let's store the texture width and height in two variables, and to access the texture, let's just add a public getter in the paintable object script. Now we can access the texture and store its width and height. Now we'll be converting the UV coordinates to pixels by just multiplying the UV x and y with the width and height. We'll also have a local int variable to store the brush radius. Now we create a nested loop from the negative radius to the positive radius to iterate over a square centered on the clicked pixel, but the x and y are the offsets from the brush center, and adding them with the brush center will give us the actual pixels that we want to paint. After that, we do a bounce check so it prevents us from accessing pixels outside the texture, and continue if it does. Now we just set each of these pixels to the brush color and apply that on the texture. Let's go back to Unity and create an empty game object painter controller and add the script. Add the reference to the camera and let's play. Now when we click and drag on the sphere, you can see that it's getting painted on those areas with red color, which is our brush color. But the sphere already has a gray tint, so I'll just make it white from the start. Let's go to the paintable object script and set the material color to white. Let's go back to Unity and play, and now it starts with white color, and just like before, we can paint on it wherever we click and drag. We can even rotate it and paint the other side. Now you must have noticed that we are painting the pixels over a square area instead of circular, and that's because the nested loops we created iterate over a square area centered on the clicked pixel. But to make the brush circular, we calculate the distance of each pixel from the center, and if it lies outside the brush radius, then we skip that pixel. So we'll only be painting the pixels inside the circle. To calculate the distance of each pixel from the center, we use the Pythagorean theorem, which is a mathematical formula for a right-angled triangle, which says that the longest side of the triangle is equal to the square root of the sum of the squares of the other two sides. Now, when we go back to Unity and play, you can see that we are only painting pixels over a circular area instead of a square. The next thing we'll do is add the ability to modify the metallic and smoothness or roughness values of the object area we are painting, just like in the game. So first, let's add the metallic and smoothness properties in the paintbrush config class. I'm using the smoothness here instead of roughness since they are basically inverse of each other. Now let's go to the paintable object script, and to paint the metallic and smoothness values, we need a metallic texture on the object, which will store its metallic and smoothness values. I'll name it Runtime Metallic. Now we'll create a new metallic texture and keep its size as well as everything else same as the albedo texture. We'll follow the same process we did for creating the albedo texture. Create the metallic pixels array. Now instead of assigning a white color like we did for the albedo, we'll create a default material color for the metallic texture, and in URP lit shader, the red channel stores the metallic value, the green and blue are unused, and the alpha channel stores the smoothness value. So we are basically having the metallic texture start with 0 metallic and 0.5 smoothness value. After that, the process is same, looping through the metallic pixels and assigning the default metallic color, and then setting the pixels and applying on the texture. Finally, we set the material's metallic texture to the runtime metallic texture that we created. We also need to set the material's metallic and smoothness values to 1. That's because the values stored in the metallic map are multiplied by the material's metallic and smoothness sliders to produce the final result. For example, if a painted pixel has a smoothness value of 1, but the material smoothness is set to 0.5, the final smoothness will only be 0.5. By setting both sliders to 1, the values we paint into the texture are used exactly as they are, giving our runtime painting complete control over the object's metallic and smoothness. At last, we enable the metallic map using the enable keyword function. Let's go back to Unity, and when we play, you can see in the material that we have a metallic texture assigned, which we created in runtime. Now, we'll be actually painting on the metallic texture. So let's go to the painter controller script, and first, we create a color variable to store the metallic and smoothness values of the brush in the red and alpha channels of the color. And then just like painting the albedo, we set the pixels of the metallic texture to this color. So different parts of the object can be painted with different metallic and smoothness values. Let's go back to Unity and test. I'll set the metallic to 1, and as you can see, the painted parts have a metallic color. Let's increase the smoothness to 1, and now the painted parts are both metallic and shiny due to the smoothness, and we can play with these values to achieve different metallic and shininess like we want. So now I'll replace the sphere with a character mesh, and this is a skinned mesh renderer which is used for animating meshes with bones. So we'll remove it and add a mesh renderer instead, and a mesh filter, and assign the mesh to the mesh filter, and the mesh collider for detecting raycasts. Now the reason we can't use skin mesh renderer is because it deforms with animations, but the mesh collider does not automatically follow those deformations. And if you see in the actual game, when they are painting, the character is in a static pose, so they are also probably using a static mesh when painting. Let's add the paintable object script to the character, and now when we play, you can see the runtime albedo and metallic textures are correctly assigned, and we can paint the character just like the sphere. One last mechanic that we want to recreate from the game is the ability to pick color from the environment and paint that color on the character. So I have a scene set up here and added the character with the mesh collider and the paintable object script, and also have the painter controller here. Now let's create a script. I'll name it color picker. Let's open it and delete the start and update. I'll make it a static class since we'll just be using this as a public helper to pick the color, and create a static function bool try pick color that will take in the raycast hit and return a color which is picked. Let's set the color to white for now. First, we'll get the render from the hid variable and only continue if it's not null, and we'll get the material from the renderer. We'll create a variable tint that will store the material tint color and set it to white for now. If the material has a base color property or a color property, then we'll set the tint color to that. Next, we'll try to sample the albedo texture if the material has one. We'll get the base map texture, and if it's not null and is readable, then we'll get the color from the texture using getPixel bilinear, which samples the color from the texture at the UV coordinates that we pass, for which we use the texture coordinate from the raycast hit. Now we multiply the texture color with the tint color to get the final color and return that. If there's no base map texture, we just return the material color. Now let's go to the painter controller script, and at the top of the update, let's do a check if we have pressed the right mouse button. Then we'll do a raycast from the mouse position and we'll call the try-pick color function of the color picker. And if it returns true, we'll set the brush color to the picked color. The color picking logic is done, so let's go back to Unity and play. And when I right click on this wooden texture, you can see that we have picked up the brown color. So let's paint this area and we are blending with the wooden part. Let's pick the wall color and continue painting on the body. And as you can see, we are slowly blending with the background. And obviously, the more detailed we paint, the better we'll hide with the environment. That's it for today's episode of Behind the Mechanic. If there's another game mechanic you'd like me to reverse engineer, leave it in the comments and I'll see you in the next one.